Hello, this is part two of the final review sheet. We're going to briefly go over five again with the Z chart just to go through that process. So, just to recall here in number five, we wanted the probability that the exam score is less than 79 with a mean of 81, standard deviation of 4. So we convert the 79 to a z-score. 79 minus the 81 is negative 2 over 4 is negative 0.5. And so we look that up on the chart. So we go to the chart, we go to negative 0.50, and we get this value here, 0.30854. And then in the second part, they wanted the minimum score for the top 10%. Top 10 is 10 on the right, so it's 90 on the left. So the table value is giving the value to the left. We're looking for the closest thing to 0.9000. So we're looking at the body of the table this time for the closest thing to 0.9000. So it's going to be on the positive side. We're looking for the closest thing to 9000. And so the closest thing here is 0.89973. 90147 is also pretty close, but 89973 is a little bit closer. So it's 1 point, the row is 1.2 and the column is 0.8. So we're going to use the z-score of 1.28. And then we have to convert that back to a raw score. Using the z-score formula, z times sigma plus mu equals x. So 128 from the chart times the standard deviation of 4 plus the 81 is 86.12. All right, number 6. A charity receives 3,012 contributions. They're independent and each have the same distribution. The mean contribution value is 2,012. Standard deviation is 190. Calculate the median contribution amount, the 75th percentile. Now, this fits the criteria where we have a large enough number of contributions, so we can use the fact that this will be approximately normally distributed with a mean equal to the original mean of 2012 with a standard deviation is equal to the original standard deviation 190 divided by the root of n, which is 3012. So it's 190 divided by root 3012 is the standard deviation. Now, since we're going to use normal distribution, the mean and median happen to be the same there. So there's nothing to calculate in that part. It's going to stay 2012. In general, though, the median cuts off 50% on the left and right. Now, the 75th percentile, that's 75 on the left, 25 on the right. So we need the left-hand viewpoint for the chart. So we're going to go to 0.75 on the chart. In the body of the chart, 0.7500, the closest thing to it. And so again, it's kind of close here between, we have a 0.74857 and a 0.75175. They're both really close. The 0.74857 is slightly closer. And that z-score value is 0.67. It's 0.67. So the z-score that cuts off 0.75 is 0.67. We want to convert this back to a raw score. So it's z times sigma plus mu. Z is 0.67. Standard deviation is 190 divided by the root of 3012 plus the mean of 2012. and that gives us $2,014.32. So that is the 75th percentile. Just to be clear, remember the mean and the median were the same. So the 50th percentile, which is the median, is 2012. So not a lot of difference there. With a small standard deviation, 190 over root 3012. So very little difference there between the the median, and the 75th percentile. All right, number 7 here. We have a counting problem. We're allowed to use the letters A, B, C, D, and the numbers 1 through 5. How many 6-digit passwords are possible if the first 3 entries are letters and the last 3 are numbers? So we start out with the letters first. Now again, we only have 4 letters to choose from. Assuming that we're allowing repeats and order matters here, we're going to get 4 cubed for the letters and then 5 cubed for the numbers. So 4 cubed times 5 cubed. Now in part B, letters cannot repeat, but the numbers can repeat. So for the letters, order matters, but no repeats. So that's a permutation, 4p3. The numbers can repeat, it's still 5 cubed. For C, it's the opposite. Letters can repeat, but the numbers can't. So that's 4 cubed times 5p3. And then if neither one can repeat, they're both permutations, 4p3 times 5p3. All right, number 8. We have 4 cats, 3 dogs, 3 goats, and 2 frogs for a total of 12. How many ways can they sit in a line next to each other? So, no restriction here. We have 12 total, so it's 12 factorial. Now, how many ways of all the cats must sit together? So we have 4 factorial ways to order the cats, and then if we think of that as one block, we have 1 plus 8 others, so that's a 9 to order, so that's 9 factorial. How many ways of the cats must sit together and the dogs must sit together? So now we have 2 blocks there. So we're going to have 4 factorial for the cats, 3 factorial for the dogs, and then we have one cat group, 1 dog group, and then 5 others for a total of 7. So we have to multiply by 7 factorial. And then finally in part D, the cats sit together, the dogs, the goats, the frogs, everyone sits together. It's going to be 4 factorial, 3 factorial, 3 factorial, 2 factorial for within each set. And then we have the 4 different types that can be reordered. So then there should be an additional 4 factorial there. So 4 factorial to order the cats, 3 factorial for the dogs, 3 factorial for the goats, 2 factorial for the frogs, and then 4 factorial for the placement of each of those groups. There were 4 groups there, so times 4 factorial. Number 9, how many 4-element subsets are possible from a 7-element set? So when you're constructing a subset, repeats are not allowed. Order does not matter. It's a combination. There's 7 total, and we're selecting 4 for the set, so it's 7C4. Part B, how many functions are possible from a domain of 5 elements to a codomain of 6 elements? So a function is single valued. Each element of the domain has to go to one element of the codomain. So for each element of the domain, there are 6 options. There are 6 choices of where to pair it. So For the first one, there's 6 choices. Then we go to the second element of the domain, 6 again, and then 6, and so on. And so the total number of possibilities is 6 to the 5th power. Part C, the coefficient of x to the 4th y cubed in the expansion of 2x plus 3y to the 7th. So this is a binomial situation here. It's going to be 7c4 as your coefficient, and then the 2x is being raised to the 4th, so 2 to the 4th. 3y is being cubed, so 3 cubed. So the coefficient will be 7c4 times 2 to the 4th times 3 cubed. All right, number 10. At a high school, students can enroll in Spanish, French, or German. 66% enrolled in Spanish, 44% in French, 34% in German, 26% enrolled in both Spanish and French, 21% Spanish and German, 9% enrolled in French and German, 5% enrolled in Spanish and French and German, all three. All right, probability of German or Spanish. So it's the sum minus the overlap. So German was 34%, Spanish was 66%, minus the overlap, which was 21%. So 34 plus 66 minus 21 is 79%, 0.79. German and not Spanish. So that's the probability of German minus the overlap. So it's 34 minus 21, 13. German given Spanish and French. So it's the probability, conditional probability, German given Spanish and French. So it's the probability of the intersection, which is the triple intersection, divided by the probability of the given, which is S and F. Triple intersection was 5%, 0.05. Spanish and French was 26%, 0.26. It's 5 out of 26. Probability of Spanish and French and not German given Spanish. So it's the probability intersection divided by probability of the given. Now, S intersect S just stays the same. So it's just the numerator's probability of S and F and G prime. And denominator's probability of Spanish. Spanish was 66%. S and F and G prime is the intersection of S and F minus the triple intersection. So it's 26% minus 5% for 21. And the denominator is 0.66. So 21 over 66 reduces down to 7 out of 22.